Fast. All right. So this is going to happen randomly. It's going to be awesome. Everybody has a chart now, right? Oh, jeez. Screw us. We're just an intersection class. All right. So what do you guys get? Anybody got that chi-square score yet? Degrees of freedom are 11. Right? Degrees of freedom are 11. And then I go over until I get to 0.05. So it looks like this one right here, right? Cool. What was it yesterday? I can't remember. I can't remember. I guessed it was around 8 because it was a smaller sample. I can't remember. One thing to notice about this is there's no symmetry here, right? There's no negatives because it starts at 0, right? Negative, what the hell would that mean? That wouldn't mean it. The difference between 2 squared is 0, is less than 0. No. Okay. So what about, so everybody's got how to look at this. So what if alpha was what do you got, Jeff? 10 and add the degrees of freedom of 50. Degrees of freedom. What's your chi-square then? So here's 50. 0.10. I get 63.167. Is that cool? All right, that's crazy. So we're really not used to numbers like this. But this is a different beast than our regular z-scores. I can look at them as accomplishing the same jobs in very often. So this idea of setting up a rejection region, same thing. But the values are going to be very different because they're based off of very different formulas. They're based off of very different concepts. We discussed how it was going to be totally not like this. And now this really shows us how it's really not like that at all. All right, maybe. Okay. So let's try a problem out. Let me give you guys, which one do I want to do? Sure, I'll do this. So this is I've done this kind of thing before. Yes. We're going to do, I forgot. We're going to do side 2 first. I had promised you we would do a correlation thing, but we'll do that second. So look at side 2. I got a problem worked out, and then I got the problem that I want us to try at the bottom. Kind of back there, Austin, sorry.
Thank you. So it starts on Monday? So we just have some Saturday, and then spring stuff. You're sure?
All right, guys. All right, guys.
Oh, yeah.
So here's a completely worked out problem about M&Ms. Here comes the next. At least they cut the sound. That was nice of them. 42 total M&Ms. Is everybody with me? Where did I get that 42 from? Did it say it in the thing? No, I just wrote down my observed and I added them up. And if I expect them to be uniformly distributed, then each color should get the same amount. Please, does it make sense that I do 42 divided by 6? How many categories are there? 6. If they each get the same amount, it's sort of like I have 42 bucks and there's 6 of us. How much does each of us get if I'm going to do it equally? 7. That's where the 7 came from. Does everybody see that? So when I say I expect it to be uniformly distributed, that's how you figure out what to put in the expected. You just cut them up evenly. And then this is what we did yesterday. We did the difference between the 2 and squared them. We had to square them because otherwise they always equal to be 0. And then we divided by the expected to make it a relative difference. Because if they're in the billions, a difference of 30 don't mean shit. But if they're in the teens, a difference of 30 is huge. So that's what this column does. Makes it a relative difference. So there's the chi-square calculated. Now double check, make sure I got the right thing here. Alpha's 0.05. Degrees of freedom. Now here's the thing. Did I talk about this? How many categories were there? There's 6. Degrees of freedom is the categories minus 1. So because math people don't spell well, it's K minus 1, where the K is category. I'm not making that shit up. K is actually a more general thing, but in this case it's category, so it's just kind of funny that it's the case. So if I had, so down here, this problem we're going to do, there's 4 categories, so what would the degrees of freedom be? Has nothing to do with the fact that there were 500 people, and we'll see that on the second problem. It's all about the number of categories. So can you look it up real quick? 5 degrees of freedom, 0.05 level of significance. Did I get the right rejection region place? Let me know if you have trouble with that. You never know about past Jeff. That guy's crazy. Okay, so nobody's telling me they couldn't fight it, so I'm going to assume everybody can fight it. And then, so since I did not make it in there, that means, so what does this region here mean? 0, of course, means that the sample did what? Did exactly what I expected. Anything in here is what I kind of also expect from just random fluctuations in samples. Just like I said, if you flip a coin 100 times and get 46 heads, you're not going to freak out. So that's the dividing line between not freak out and freak out, and we only made it there. So our sample was not very far away from what we expected, therefore it's not evidence that they're not uniformly distributed. And one thing you gotta love about math is that double negatives are fine, right? So give me some English shit about what I just said. We have not found sufficient evidence to say that they're not uniformly distributed. You guys with me a little bit? Because what would it mean if I got way out here? That would mean that's evidence they're not uniformly distributed. Because it would be so different from 7s across the board, that's evidence. It's not proof, but we didn't make it anywhere near far enough. Okay, maybe. So you don't have to be as formal in what you state, but you do have to capture this idea somehow. Do you guys see it? So I try to be very formal in the way I said this. You don't have to be quite as formal. I'm not going to make you do the whole hypothesis test. So look at this second dude down here. Yeah, this one I try to help you out with. This is the second type of goodness of fit we're going to work with. I don't tell you they're uniformly distributed, but I do tell you the percentage I expect in each category. So continuing my feeling out what it's like to be nice, I expect to see 20% of 500 in this first category. So what's the whole idea behind this? Do you guys remember, or have you heard of, remember, because you weren't around, back when they realized that everybody around the Mediterranean were in great shape, for the most part, right? Much better than Americans, which isn't really hard to do. And so everybody just started guzzling olive oil. It's olive oil. Let me get my 2 quarter pounders and just guzzle some olive oil. Everything's great. I don't know if you guys remember this. So this kind of study could lead to misunderstanding because it's not enough. So we see this group of 500 people in this secluded area, and they're eating some certain diet, very different diet. And that's the only thing that we can kind of ascertain is different. So then we say, okay, let's look at their cholesterol levels. Here's what we expect. Let's see where they are, and let's see if it's really far, because they all seem to be pretty healthy, so we're really curious. This by itself would not be evidence that it was the certain diet they're on, right? What else could it be? Besides just what they're eating. They're eating weird stuff that's out on the island. You know, we don't have that kind of fruit or whatever it is. Yes?
Culturally, they're more active.
Yeah, exactly. So they don't have cars or something. They're more active. They're constantly, maybe they have these cliffs that they live on and they have to climb up the cliffs. Have you ever seen the cliff dweller kind of things? Or what else? Maybe it's their genes. Maybe it's their genes, right? We don't know. But, this is somewhere to start. We'd have to do more specific tests about the diet and give some people the diet and give other people not the diet and wait several years and see what happens. But this is just to tell us that they seem to be different somehow. So fill those in. What is 20% of 500? That's right, kids. Are you all doing it in the calculator? Oh my God. Holy shit. That button got stuck. All right. Oh, yeah. Oh no. Oh, well here, you can borrow mine. What else we got? What's 30% of 500? That should be the last ghost.
175.
Goes to Fire's future? I don't know. 35% of 500 is,
175.
and 15% of 500?
75.
Beautiful. Do these all add up to be 500? That's a good check, just to make sure you did the percentages right. And sure enough, they do.
Yes.
Yes, sweet. Now what goes here? Now real quick, somebody see, I can either tell you they're supposed to be uniformly distributed, and they all should be the same. Yes. Well, yeah, come here. Or I'll tell you what percentage should be in all of them, and you have to calculate that. All right, so what should go here? Yeah, we see that there's 118 with a level below 130. What should go here? 198. Is everybody with me? Or are you guys just not? That's right. It's like I just met you. You guys don't like to talk. And then what goes here? 131. Have it between 200 and 240. And then, of course, I got to figure out what's left over for the last one. 53. Is that right? All right, let me stop for a minute. Does everybody see where all those numbers came from? All right. If you read the there, observed, I have to just tell you what we saw. How many had a level below 130? 118. Bam. Below 130, 118 had that. You keep going, you get 198 had that. I have to tell you exactly how many we saw in each category. Okay. All right. Now, just do this. Subtract them and then square what you get. I'm trying to make this a little less extreme, but it's still kind of extreme. Do I have any calculator?
Yeah.
Let's see, what is that? Was that 364? Oh, 40. Let's see. Four. 2404? 3. That's 44. 1776.
1936.
1936. And then let's see. Can you get a single one right? That's going to be 324 here. No, it's going to be 22,444.
Yeah.
Yeah.
444. 484.
484. Excuse me. I'm trying to do it in my head real quick. All right. So So that's not that major. We've done that kind of thing before. We discussed yesterday why that makes sense with what we're trying to get a hold of. That's the thing to remember. It's what I always hate when I see instructors just giving people a formula without explaining what the hell it's trying to do. The more you know what a formula is trying to do, the more the formula makes sense. The easier it is to remember. And then here, I just got to divide by the expected. This first one's easy. I think I can handle that one. This one, I don't know. Shit. 46, 3. It's going to be 15 point something.
15.36.
15.36? Oh shit, I'm not even going to try this one. 11.06? Who is it? 6.45? Okay. Does everybody see where those numbers came from? And you're lucky. I'm actually gonna give you those table headers on the problem itself. You with me? You just have to actually do it. Which I normally wouldn't do, but you know, shit. How much are we working with this? One day, so I'll be a little nice. The chi-square formula is the sum of these bad boys that we just did. So if you add those up, 36.11?
Mm-hmm.
All right. So I don't blame you. See, what I just did was I calculated the sample stuff first. It's sort of like the fourth step in our normal, who gives a shit. Now I got to figure out what the score is to compare that to. So remind me, degrees of freedom for this problem is what? Trace. Gracias.
Should we go with 3 digits on the chi-square since the chart is 3 digits precision? Or is
It doesn't. Yeah, trust me. You only have, well,
It won't be that close.
if it was really close, you would want to increase your precision. But I'm almost certain this is not going to be close. I don't remember. We'll see. So degrees of freedom is 3. Alpha, I tell you, is what? 0.01. Everybody see that? Right there. What does LOS mean again? No. Los Lobos. No. No, not line of sight. Not linguine or spaghetti. No.
Level of significance.
Level of significance. No, that's silly. No, that's the one. So, degrees of freedom is 3. Level of significance is 0.01. Where's my rejection region? Can you find that on the chart? What was that, Shelly? Los Spookies. There's a Shelly. There. So alpha is 0.01. And then I stop at degrees of freedom of 3. I get 11.345. Is that cool? You guys see that? So that is a very different number than we're used to, but it accomplishes the same thing. It sets up where evidence starts. And where did we get? You got freaking 36, right? You blew the shit out of this. Is that evidence that they do not follow the expected cholesterol pattern? Yes. Now, we can actually go a little bit further, because is it better to have lower or higher cholesterol? That's amazing. We can notice, so all this test by itself said is there is a difference. There's evidence that there's a difference. But we can see that they have more people with lower cholesterol than expected and less people with high cholesterol. So therefore, we can make it more specific. We can say there is evidence that these people have a better cholesterol level than would be expected. Is it their diet? I don't know. Now we have to set up a secondary test and see what it might really be. Which variable that's different for them would be affecting them like this. And if it's genes, too bad for you people, right? Too bad for all of us. But if it's a freaking fruit they're eating, you know it's going to be in a pill form and everybody's going to sell it. And that's already happened so many times. It's crazy. Okay. How do you guys feel about that? Is not as bad as I might have made it sound like it was going to be, but I knew if I hit you with another chart the day after we did hypothesis test, you might have freaked out a little bit. So let's do this. Let's do this example here together. And then I have a handout with a problem of both types that I want you guys to work on by yourself. And then I'll give out then we'll do the formula sheet. We'll get into review for the final. Okay, that's the plan. Who needs this? Oh, you need this too. Bless you. So now we're looking at side 1. Does anybody else need a calculator? Nobody? All right. So I'll try to exist. I gave mine away. So why don't you guys, now listen. What kind of problem is this going to be? What are you going to have to find from this data? It's a regression correlation problem, right? So these are my x's, these are my y's. If you put them list 1, list 2, you can do the lin reg. You can find the line of best fit. You can find the R value. Now listen, I think I said this before. When I give you a percentage and you want to calculate something with it, you have to change it into a decimal, correct? We're about to create an equation. If I use the percentages as percentages, our equation will be able to handle percentage numbers because we're going to create it. So if you leave these, you don't have to make these decimals. Leave them as they are. Your numbers will come out a little better, so you'll, right? So put this into L1, put this into L2. Try to get as far as you can on this problem. Where are we at? What's up?
You said too much.
Oh, you just wanted something? I'm going to go grab another calculator so I can have one.
So